Okay, guys, we almost got there. So we're at the end of the experiment. We're going to do data analysis now. So the student added the amount of H2O2 calculated, the 2.02 milliliters, to the excess NaOCl. So the reason it keeps telling us it's excess is that it's saying that doesn't have any effect. There's enough of that. So we can assume that all of the H2O2 reacted. But instead of producing 40.0 milliliters of O2, the volume indicated in the diagram below was produced. So this is part F, a little lab section here. Based on the diagram above, what was the volume of gas? So it's in between the 30 and the 40, so I know it's for sure 30. And then it's 1, 2, 3, 4, 5, for sure 5 lines down. But remember, you're going to measure to the bottom of the meniscus. So that one I would say is below the 6, so 36. And then we can estimate that final digit. So I would say that it's maybe about halfway. So they're going to give you, I think it's plus or minus, let's see, plus or minus 0.1 maybe. So like 1 above, 1 below of that value. And then of course, make sure you include your units. Okay. Part 2 is asking, assuming that all the gas in the tube is O2, calculate the percent yield. So this is going to be actual over theoretical times 100. So we actually collected 36.5 milliliters. We were theoretically, with our stoichiometry, supposed to collect 40. To get it to a percentage, we multiply by 100. So we had a 91.25% yield. That's pretty good. Part 3 is the assumption that all the gas in the tube is O2 correct. Explain. So in our gas collection tube, it says that we've set it up. The flask is connected to a 50 milliliter gas collection tube that's initially completely filled with water. So that is our key here, is that initially it has water and it's also over water. And so we know that any liquid has a few molecules that escape it, even if we're not at the boiling point. So this one is going to be a no. It's not going to be pure O2. It's going to contain some water vapor because it's over water. It also might have O2 bubbles if we want to get really specific. You wouldn't need to include both of those things. You would need one or the other in your answer to get that one correct. And then finally, last one, to account for the percent yield being less than 100, the student claims that the reaction reached equilibrium before the expected amount of O2 was produced. Considering your answer to part D above, do you agree or disagree with the student's claim? Justify your answer. So you guys, any time that they give you a section to look back at, you want to do that because it's going to give you a hint as to what they're looking for in the answer. So when I go back to part D, we calculated K. And I kind of alluded to this when we did this calculation, but this huge value, it is so much greater than 1 that we're going to assume this reaction goes completely to finality. It is going to completely go to the products. There is not going to be any of the reactants left because it's so huge. So what we're looking for part G is that we're going to disagree because that high K value means that it's almost all product at equilibrium. So there's a really small chance that it reached equilibrium before all of that H2O2 was used up. For sure not 9% left. Okay, you guys, come tomorrow with any more questions. Hope you enjoyed the video.